Sixth grade lesson 11.7 is problem solving and geometric measurement. Basically, this is a practice session, but really kicks it up a notch to make sure that you are paying attention to detail. So I would suggest in all of these that you read the problem, just like always, read it carefully, maybe read it twice, and of course we'll go through our steps. Read the problem, read the question, underline the question it wants you to solve, circle the information they gave you, maybe highlight those details that are going to come into play, because there's going to be some other details that come into play on these, and then make a plan to solve. So let's have a look at an example. Alright, on our Unlock the Problem, we have the Shed Aquarium in Chicago has one of the country's few full-scale animal hospitals linked to an aquarium. One tank for sick fish is a rectangular prism, measuring 75 centimeters long, 60 centimeters wide, and 36 centimeters high along the outside of the aquarium. The glass on the tank is 2 centimeters thick, so all the way around you've got this 2 centimeters in, right? How much water can the tank hold? How much water is needed to fill the tank? Okay, I feel like those are the same answer. How much can the tank hold, and how much water would I need to fill the tank? If it can hold a certain amount, that's how much water would fill the tank. And I did not see anywhere in here that there's already some water in there. That could have been a detail that would have made these different answers. But if I find out how much it holds and it's empty right now, then how much I need to fill the tank is going to be the same value. So that's that piece of information. We underline the question, we circle the information that was given to us, and we kind of already have it in the drawing for us, so we don't need to make a drawing. This glass tank issue, that's a key piece of information too, that we're going to have 2 centimeters thick. We're going to have to, that's the details. Remember I said you're going to have to read carefully, you're going to have to pay attention to details, you're going to have to ponder and puzzle this through. All right. I've put our formulas over here that we've learned in our geometry so far for area of a parallelogram, base times height, including rectangles and squares, area of a triangle, 1/2 base times height, area of a trapezoid, 1/2 times base 1 plus base 2 times height, and volume of a rectangular prism, which we've been working on recently, is length times width times height. And we are looking for volume. Remember, volume is filling things up. So we are looking for volume on this one. So we would use this, and normally we'd say, okay, length times width times height, right? There's an issue here though. This is the detail we need to pay attention to. There's this 2 centimeter glass all over the place, right? So I'm just looking at how much water fills that up. Well, if this whole piece of glass is 60 centimeters long, the water is not 60, the area the water is going isn't 60 centimeters, because I have to take 2 centimeters off from this side's glass and 2 centimeters off from this side's glass. So it would be 60 minus 2 and then 2 again, so 60 minus 4. You see them doing that down here in the planning. Then I have this 75, the width, but that's the whole outer part of the glass. I need to know the inner part so I know how much water I can put in. So take 2 centimeters off from this side, and that makes it 73, and then 2 from this side, making it 71. That's what they're doing right here. And then my height is 36. Now, again, still ponder. I don't have glass on top. I need that to be open, right? I need that to be open so that I can get the fish in there. So the bottom has 2 centimeters, but the top does not. So I'm going to do 36 minus 2. So you can see it's not so much what calculations I need to make in this case, it's my reasoning. I have to think this through. So that's part of the planning. And they give you this placemat of planning that can help you reason things through if you want to. Sometimes you may not need it, or after a while you may not need it, but we'll go ahead and fill this out so you have kind of the plan there. I need to find the volume that the tank can hold and the amount of water to fill. How much fills the tank? What information do I need? I need to use the dimensions, the length and width and height. And the formula for volume of a rectangular prism. How will I use this information? Well, first, I will decide that I need to find volume, I guess. I'm not exactly sure what they want here. Then I will choose the formula I need for volume of a rectangular prism and use that to calculate the measures. Finally, I will substitute the values of the dimensions, the 60, 75, and 36, and then I will calculate the formula, I guess. I don't know. I think those are reasonable answers, I suppose. Choose the measure that specifies the amount of water that will fill the tank. So I'm going to start with these 60, 75, and 36. I'm going to start with that, but I already know that there's some issues with that 2 centimeters of glass that I've got to address. And the appropriate formula, length times width times height for volume of a rectangular prism. Here's where they help me plan this out and get these measurements correct. This 75 is the whole length of the outer glass, but let's take 2 centimeters off over here and 2 centimeters off over here because we want to know how much water fills in there, and the water's not going where the glass is at. So 75 minus 4 is going to give me 71. Then we're taking this 60. Again, 60 is the outer part. Take 2 centimeters off from this side and 2 centimeters off for the glass on that side, making that 60 minus 4, which is 56. And then I will do 36. The top is open, so I don't have glass bothering me there, but 2 centimeters taken off of the bottom. 36 minus 2 is 34. So in the beginning when I said, this is all the stuff you've been doing, you were really good at this already, finding volume of a rectangular prism. Now it's just a little bit of attention to detail. Oh, I have to take 2 centimeters off because of the glass. That's what you're going to see in this lesson, is those sorts of little twists. You can perfectly handle it. You just need a little time to digest the information they're throwing at you, and then you calculate like you've been doing. So we're going to do 71 times 56 times 34. I don't know if they wanted me to calculate that or they mistyped that equal sign as instead of multiply. But I'm doing 71 times 56 times 34. I'll calculate that. And on my calculations over here, that got kind of messy. Try not to make your math messy. It makes for potential mistakes. I went messy there, so this may not be quite right, but I may have made a potential mistake. But I'm going to hope it's right. 135,184 centimeters cubed, remember, because it's a 3-dimension. They give us one more example of a problem that we may face. Let's take a look at this one and see if we can plan out what we need to do. We'll start by reading it. We may have to read it twice or 3 times. We'll underline information, circle it, draw what we need to. They have drawn some things for us, so maybe we won't need to. Alexander Graham Bell, the inventor of the telephone, also invented a kite made out of cells shaped like triangular pyramids, a bunch of little triangles in there. A kite is made of triangular pyramid-shaped cells with fabric covering one face and the base of the pyramid. The face and the base both have heights of 17.3 centimeters and side lengths of 20 centimeters. How much fabric is needed to make one pyramid cell? So it looks like we're focusing in on one little pyramid cell and bringing it over here, and they put our measurements 20, 20, 20. It looks like every measurement along that is 20, and the heights 17.3 all the way around. So I have these triangles that are 20 and by a height of 17.3, and all of them are the same on the cell. I'm assuming, it's hard to tell in this picture, I'm assuming that all of the triangles are filled. So that's something I will take into consideration. How much fabric is needed to make one pyramid cell is my question. The face and base both have heights of 17.3 centimeters, lengths of 20. And if I need to find the how much fabric on the whole outside, I'm not filling this up with anything, am I? I'm not filling the 3-dimensional figure. I'm covering the outside of it. So hopefully that sparks in your brain that I'm not doing volume on this one. I am doing the outer area, the surface area. So when we did surface area, first of all, we would take the area of, in this case, a triangle. Area equals 1/2 base times height. And I'm going to try to determine what are the shapes, what are the shapes and how many of them are there. Well, this is a triangle, 1, 2, and then this front 3, and then the bottom, which is the same dimension. Sometimes the base isn't the same dimensions, but in this case, it is the same dimension. So I have 1, 2, 3 the face, and 4 the bottom, 4 triangles that are all the same dimensions. So I'm going to, when I find out what the area of one of those triangles is, I will multiply it by 4. Okay, what do I need to find? It turns out I need to find the surface area, how much covers the outside of it. What information do I need to use? The formula for area of a triangle. How will I use that information? I'll calculate what the area of one triangle is, and then I'm going to multiply by 4 because there's 4 of them. All right, so they give me room. Thank you very much for giving me room to do this. Area equals 1/2 times the base 20 times 17.3. I'm going to do this half of 20 right away because that's an easy half to do. Half of 20 is 10. Okay, and then 10 times 17.3, that's just moving this decimal 1 spot because of the 1 0. So my area of one of them is 173 centimeters squared. I have 4 of them, so I will go ahead and do that calculation. 692 centimeters squared of fabric is needed. Explain how you knew which units to use for your answer. Well, the whole thing was in centimeters. Info was in centimeters, and area is to the 2nd power squared. Okay, this whole thing, like I said, read it carefully, pay attention to detail. There may be extra detail that you've got to massage the information, adjust it, like the 2 centimeters of glass on the previous one, make some slight adjustments. It's like exercise for your brain. You know these formulas now, it's applying them, but with extra information that sometimes gets thrown at us. You may want to write down these formulas just to have them handy. Area of a parallelogram in case you come across that. Area of a triangle if it's not memorized yet. Area of a trapezoid in case, pretend that's a trapezoid, sorry, that's very sloppy, I can't, you understand what I'm after. 1/2 times base 1 plus base 2 times height. And then volume of a rectangular prism, length times width times height. So those are some formulas that may come into play throughout this lesson. Write those down in the top of your page so you have them nice and handy and you don't have to flip the books all over the place to try and find it. So there you go. My advice, just read slowly, read carefully, pay attention to detail. Don't be afraid of these. They're just a big puzzle. Let's see how you do.